Let us talk about another operation we perform in number bases, which is subtraction. Now, we know how we subtract in our usual base, our base 10. When we are subtracting in base 10, usually when we borrow 1 from the next item, that one usually represents the base, which is 10. For example, in base 10, when we are to solve these two numbers, 84 minus 38, we know that 4 is less than 8. We need to borrow 1 from 7. So from 8 rather, so 8 becomes 7. And that one we borrowed will become 10 because we are working in base 10. So it will be 10 plus 4, and that's 14. And then we can then solve the equation. 14 minus 8 gives us 6, and 7 minus 3 gives us 4. So the point is, in a base, when you borrow from the next item, that number you borrowed, that one you borrowed is equal to the base. So this is base 10. Since I borrowed 1, is equal to 10. So that's one idea we want to keep in mind as we solve some examples of subtraction in different bases. Let's look at some examples now. Now, 24 in base 5 minus 13 in base 5. What's the answer? This is our regular subtraction, nothing special. So 4 minus 3 is 1, and 2 minus 1 is 1. So the answer is 11 in base 5. What about if we have another example? 5117 in base 8 minus 324 also in base 8. Now, 7 minus 4 gives us 3. But 1 minus 2 is not possible because the 2 is bigger than the 1. So we therefore have to borrow 1 from the next item, which is this one. So this one becomes 0. That one which we have borrowed now becomes the new base, which is 8. So it's going to be 8 plus this one, which is 9. So we then have 9 minus 2, which is 7. The same we are going to do here. We now have 0 minus 3. It cannot go. So we have to borrow 1 from this 5. This 5 is now 4. But that one we borrowed will become 8. So it becomes 8 plus 0, which is 8. So that 8 minus 3 is 5. And then the 4 minus 0 is 4. So the final answer is 4,573 in base 8. So take note that whenever you borrow an item, when you borrow 1, that 1 represents the base. So since we are working in base 8, anytime we borrow 1, that one is going to be 8. Let's solve some more examples. Let's work in base 6. So let's have 3215 minus 1552 in base 6. Now, 5 minus 2 is straightforward, and that's a 3. But 1 minus 5, we cannot go. So we have to borrow 1 from this 2. This 2 becomes 1 because we've taken 1. And that 1 we took becomes the base, which is 6. So it becomes 6 plus this 1. That's now 7. So 7 minus 5 gives us 2. We are left with just 1 here. And 1 minus 5 cannot go. We have to borrow 1 from the 3, which is 2. This is the same regular subtraction we are used to. The only difference is that whenever you borrow, that one you borrowed becomes the base. So since we always work in base 10, that's why anytime we borrow 1, we call it 10. But we are working in base 6 now. So we've borrowed 1 from here, and that one is going to be 6. So 6 plus this 1 is 7, minus 5 is 2. And then 2 minus 1 is 1. So the answer is 1,223 in base 6. Let's solve another example. Let's say we have base 9 to work on this time around. Look at this question. It looks a bit tricky, but if you understand what we'll be saying, you can solve it. 11111 in base 9 minus 9999 also in base 9. Now, this is going to involve a lot of borrowing, as you can already predict. So 1 minus 9, it cannot go. It means we have to borrow 1 from this next guy. This one becomes 0. And that 1 we borrowed becomes the new base, which is 9 plus 1. So 9 plus 1 is 10. 10 minus 9 is 1. Now we have 0 here, minus 9, it cannot go. We have to borrow from this guy, and this becomes 0, and that 1 we borrowed becomes 9. So 9 plus 0 is 9. 9 minus 9 is 0. We also have 0 here, it cannot go. We have to borrow from here. This one becomes 0, and that one we borrowed becomes 9 plus. So 9 plus 0 is 9, minus 9 is 0. We also have this number here, which is 0. 0 also cannot minus 9. We have to borrow from here. This becomes 0. And as it becomes 0, that number we borrowed will be 9. So 9 plus 0 is 9. 9 minus 9 is 0. And this 0 will bring it down 0. So the final answer is just actually 1 in base 9. So that is the concept of subtraction. Whenever you are borrowing, that number you are borrowing becomes the new base. So if you are working in base 6 and you borrow, that one you borrowed is going to represent 6. That is just the principal idea to keep in mind when working in other bases. Now, can you try? Try and subtract these numbers from each other in the respective bases. We have 2,347 in base 8 minus 1,464 in base 8. And also we have 3,101 in base 4 minus 2,333 in base 4. Lastly, also try and solve 1,0,101 minus 1,0,001, both in base 2. Thank you very much for watching this video. Drop your answers to these questions in the comment section and ask any questions you have. And please don't forget to like, share, and subscribe. Thank you.